Hello everyone. Today I wanted to talk to you about an extension to Geoviews that adds spatial data awareness to the visualization libraries that we've looked at. So if you haven't already, please do install Geoviews, and also, we'll see later on why, install a package called Fiona. And you can just use the conda environments that you have used in the past, and just what you would do would be this here, which we're not going to run, but at least it gives you an idea of what line you need to use for it. So I'll just leave it here, comment it out. But let's import the modules, assuming that everything has gone well. You should see this little logo here. Now, let's actually open up. Okay, let me zoom in a little bit. All right, here we go. So by default, Geoviews assume essentially the lat-long projection, and it's what you will find with a lot of the Google Maps that we'll be using as background for our maps. But that doesn't mean that that's the only projection we have to use. The nice thing about Geoviews and Cartopy is that they allow for on-the-fly reprojection. So what we're going to do here as an example, we're going to look at the ability of Geoviews to put geographic points on a map. So we've got New York City, and as you can see, that's a tuple that has three elements: the longitude, the latitude, and a string, which is the label. And we have London, Beijing, so we have these 3 points, and what we do is we create a Geoviews Geoviews object. Remember, with Geoviews we were doing hv.dataset, hv.curve, and so forth. Same thing here, so same sort of syntax, but in this case we're going to use gv, as that's the alias we're using for Geoviews. So we've got points, gv.points, and then we pass the list of these tuples. And then what we use for the value dimension, so we give it a name and just say it's city, and then we set up for our canvas, we set up the entire extent, and here we are grabbing the global extent. So from -180 to 180 longitude, -90 to 90 latitude. Now, if we just save this as the points object, it's not going to print anything, right? Everything is saved, the data and the visualization is saved in the points object. But what we're going to do is we're going to look at some of the hidden metadata associated with points, which is the default projection. So if we are given an object, a Geoviews object, we can query it for the projection and some other metadata that we can explore using the tab completion mechanism. So as we've done before for Geoviews, we can use the OPTS options, keyword and function, and what we say here is, here for the points, make them size 6, then change the width and height of the canvas, because again, remember, the points has this is the extent, it has the global. And let's actually comment out this part here, and we'll see what that is. But let's do the points. Here's where it is. So we see 3 points. Now, under Y we have the latitude, the X we have the longitudes, and you can sort of guess that these are the correct cities, but that's not very useful, is it? So what we're going to do is we're going to use the Geoviews feature subpackage to add some contextual information, and in this case we're going to overlay borders and the coastline. So let's run this again. That's better. So now we can confirm that in fact we do have London, Beijing, and New York. And again, we get all the nice things that Geoviews gives us: zoom, pan, and so forth. And as you can see from the borders, we get pretty much relatively crude resolution, but it's nice because if we want something fast, and if we're using for global map, I mean, that doesn't really gonna make much of a difference. There are some options, we'll talk about them later, of how to get even higher resolution coastlines or borders. Actually, not borders, coastlines. Especially, if you wanted to see something in Southeast Asia here, you can see that it might be good to get higher resolution. In any case, Let's look at some of the capabilities of Geoviews. And the first one is the reprojection on the fly. Here we had a lat long projection, but what we're going to do now is we are going to set some options in a different way than we've done before. Remember, before we would operate on the opts method of the HoloViews Geoviews object, and we pass the options. Now, as we pass the options as a, remember, as a dictionary essentially. But now what we can do is we can create an options object. So we have gv.opts. And then if we wanted to set up the options for points, which we do in this case, we have projection, width, height, global extent true. And again, this is we can do the same thing but with a different syntax than we did before, but again I wanted to show something slightly different just to give you the different possibilities. And then we do the same thing. So now the only thing we changed again is just change the projection. And remember, the points object has metadata associated, so it knows what its projection is. So when we're asking for the Robinson projection, it knows how to convert from one to the other. So all that is transparent to the user, us. And again, makes for some very nice ways of visualizing different projections. Now, on top of projections, one other feature that I really like is the ability to add base maps to our data. So in order to do that, we were going to use something that's called tile sources. The reason it's called tile, I mean the sources you get, right? We can get the base map from different sources. We can get it from Google, we can get it from Esri, there's multiple sources. The tile part is the fact that when they're stored in the cloud, in order to allow for quick access, everything is stored in tiles. So that's really what all it is. So import Geoviews tiles underscore sources as GTS. Again, we're given an alias, so we don't have to write this whole thing every time. So what we're going to do here is we're going to see another Geoviews object called layout. And by layout, this essentially allows us to plot different maps as subplots. The same way we've done with matplotlib, we can do the same thing here, but have a specific layout. And in this case, the layout takes a list of Geoviews types objects. So let's just go through this line in more detail, and let's start with different components. First of all, this whole thing, remember, because it has brackets everywhere, up to here, let's say, it's a list comprehension. So instead of having a for loop, we have the for loop within a single line. So here what we're doing is we're saying for name TS in GTS tile source items. Now GTS tile source items will give us tuples back, and the tuples are going to be a name and the Geoviews object, which here we're calling TS. So as we're looping through, we're essentially grabbing tuples each iteration, and we're storing the first part of the tuple under name, which is a string, a label, and then the Geoviews object, the map itself. Now, because I don't want to create too many of them in the layout, and there's 16 of them, what I'm doing is I'm essentially saying, hey, from this list that you created, just grab every 2 out of 16. So, and again, we'll just look, it's just for visualization purposes. The only other thing we do is we just relabel the object just to add a new title, and we're using the name of the that we get from the tiles. So that list essentially becomes a layout, and when we call the options to the layout, we can say don't put any axis ticks or labels or y-axis ticks or labels, set the width and height, and then create 4 columns. Remember, we have originally we had 16 items, we pick every 2, so we end up with 8 items, and we asked it to have 4 columns. And here's what the different sources look like. We have Carto Dark, Carto Light, Stamen Terrain, Stamen Watercolor, Stamen Toner Background, and some other, and then some from Esri as well. So if you're interested in the different possibilities, I mean, you can go look in the Geoviews gallery or documentation and then when you go to the tile sources, you should be able to see what is available. But again, if we have the layout here, we can overlay by saying multiply by, and then add points and do all kinds of things to again create some relatively complex maps with as few lines of code as possible. Now, the other thing I wanted to look at is GeoPandas. And the same way that Geoviews is an extension to HoloViews, GeoPandas is an extension to Pandas. And it allows us to do the type of analysis that we've done before with the same sort of Pandas functionality. So the first thing we're going to do here is, and this is why you need Fiona, the module. So if you get an error, it's going to tell you install Fiona. We're going to use the read file. And the GeoPandas does have some default data sets that we can use. And here we're going to use the natural earth. And if we Google natural earth, you'll see some of the data sets that are free vector and raster map data. So there's really a lot of them out there. So you'll see cultural, physical, raster. So you have medium scale, small scale. So if you go to the physical large scale, again, you can see coastlines, land masses, minor islands, reefs, ocean. So again, a lot of this stuff is already available, and the nice thing is that GeoPandas can read all of them directly. So let's just grab the low res, and we're just going to save it under world. Now you see the familiar format of the pandas data frames, and we have a column that shows an estimated population, the continent, the name of the country, the three-letter code of the country, the GPD of each country for a particular year. I don't really remember which year it was. And now here's the interesting part. Here's what GeoPandas adds. It adds this geometry column. This geometry column is again something that describes the spatial attribute. So Africa, Tanzania, it's in Africa, and then it's a polygon. So essentially this column tells Geoviews or any other mapping library that we use how to plot each row. So by having this information, now we can do things like plotting the GPD per country. So the way we're going to do it is, because these are polygons, we're going to create a Geoviews polygons object, and now instead of passing a list of cities like we did before, now we're going to pass the GeoPandas data frame. And we're going to tell it, hey, as value dimensions, use the GPD, and then use also the continent, and also the name of the country. And then we're going to set some options. We're going to set the width and height, we're going to enable the hover tool, we're going to set the color map, and then we're going to say, just don't plot the entire world, just, plot latitudes between -60 and 90. So let's see what we get. Again, you can sort of ignore these deprecation warnings for now, but here's the type of map we get. And you see that each country is separate, it's plotted with a color. And as you can see, the color corresponds to the GPD. But at the same time, because we added the continent and name as the value dimensions, we're also getting these attributes when we hover over. So and again, you can get the same things with that we get with all the HoloViews objects, which is the zoom options and pan options and all that. So again, very nicely, just one line to read the data, and then 2 lines to create a map like this. Which again is interactive and shows information coming from the Pandas data frame directly. So what the hands-on exercise, and again you can try it out without going over the solution here, but what we're going to try is to plot a world population map, and you see the different cities here have different population sizes, and then the size of the circle is corresponding to the population size. But the nice thing it's that we have different years. So then we will add a slider here to essentially give us this plot for different years. So we're going to grab the data using pandas this time, not GeoPandas yet. So we're gonna have them by using this CSV file, and we'll see why we're actually using pandas and not GeoPandas. The reason is that we don't have the geometry column that's already available in this data set here when we're reading the natural earth. So here we sort of have to do a little bit more legwork to actually get it to the format that we need. But in any case, we still get a data frame, but this time we know we have the city name, the country, the latitude, longitude, the year, and the population. So why don't we create, first of all, a data set. So let's, and this is the legwork that I was talking about, let's create a data set here from the city's data frame, and now we are using key dimensions. And key dimensions are different than value dimensions, right? Because key dimensions essentially will allow us to separate out essentially the index from the value. So you can think of this as the index. So we're going to index this data set based on the city, the country, and the year. Now the value dimension is where the population is going to be. So the next thing we're going to do is we are going to convert these data here to points, because that's essentially what we're looking for. So we go population dot to, and then we can use any type of Geoviews object. So in this case we want to convert that into points, and here's where it gets interesting. The points will need an X and Y. Remember from the cities we were passing the longitude and latitude, right? This is the same thing we're doing now, and we're saying here's the columns that you need to use to pass to the points, and then we pass value dimensions. But the value dimension that's the most important one is the first one, because that's the one that's gonna tell us what color to use, right? Remember from this one here we used these value dimension, we used the GDP for the coloring of the values. The same thing here, but because we also want some additional information when we hover, we add the city and the country. So the fact that they are key dimensions here does not mean that they cannot also be value dimensions. On top of this, we also create some tiles, and in this case we grab some tile sources from Wikipedia, and again if you use tab completion you can see the Carto Dark, Carto Light, Carto Midnight, and the different available tiles. So let's do that. We just did. So population is data set, points is the conversion of that, and now the only thing we have to do is have the tiles and then overlay the points. And here's where it gets a little bit interesting. So we're gonna go slowly through the different keywords. So first of all, we are being explicit that we want population to be the colors of the points. We're setting the color map, and then this is how we're going to get different sizes for the circles. So we're going to set the size, and we are going to use the population, but to convert to points or inches. I mean, you can set the unit yourself, but here it's points. But because the numbers are fairly huge compared to points, so we're gonna just multiply by 10 to the minus 6 to convert the population to a point. And we enable the tools, global extend true, and the other stuff so that you've seen before. So the two things that are different here is the color and the size. So let's take a look. Right. Now, because the year is a key dimension, and when we convert it to points, it's nowhere to be found here, right? Because we essentially promoted or at least changed the city and country as a value dimension. The year is the key dimension, and that's the one that's being used here. And you can see the different sizes, right? So look at that. We've got longitude, latitude, population, city, and country. Population, city, country. And now if we go 1955, 1960, 65, 70, 75, 80, can sort of start seeing how we're using the key dimensions, and here's the future population to actually perform this. So again, very few lines of code to accomplish a result that's again could be very complex, and we get all the other nice things with it. Alright, so hopefully this gave you an idea of what Geoviews can do. Again, very powerful tool, and very little code required to, again, get a result that's pretty cool. Alright, we'll see you soon.